things are gonna get nasty here, okay? So I encourage you to do this video like 1,000 times until you understand what's gonna happen here. Okay, we're gonna use a bunch of trigonometric properties, um, and yeah, you need to review that first maybe. Things are gonna be a little bit odd. There's like gonna be a lot of math involved here. That's not that hard, okay? So you're told you just have one thing of data. You just get the initial velocity. But with this, you can set the conditions for getting like the maximum height being equal to the horizontal range, okay? So pay attention to this. If you remember, we saw a formula that we haven't used until now, and it's this one. The range, that means the horizontal distance, is equal to the initial velocity squared over the gravity, which we know, of course, uh, times sine of 2 times theta. Okay? We want to know the angle. Okay? And we know those two things, so we're just missing the angle. Okay? That we can live with that. The next thing we know, we can't rely on time. Okay? And most of our formulas use time. There's just one that's just like useful for us, and it's this one. The final velocity in y is gonna be equal to the initial velocity in y squared minus 2 times the gravity y minus initial y. Okay, so we're gonna rely in those two formulas. Now, what happens here? We need to modify this one so we can have everything in terms of sines and cosines. Okay, so this formula is gonna turn into, at the highest point, final velocity is gonna be 0. The initial velocity is gonna be initial velocity sine of theta, and all the stuff is gonna be squared. Okay, minus 2 times the gravity. We want to find the maximum height, and we know the initial height for sure is 0. Okay, so we're left with this. Now, we need to solve for this y. That is what we need. Okay, so solving for y, we know that the initial velocity squared times sine of theta squared over 2g, that's equal to y. Okay, now we want to make that maximum height equal to the range. Okay, so these two numbers should be equal. Okay, so we make them equal, and that is v0 squared over g is gonna be, well, times sine of 2 theta. It's gonna be equal to v0 squared times the sine of theta, all that squared, over 2g. Okay, now we need to notice that there are like the same elements on both sides of the equation, so we just like can get rid of things. Okay, there's a v0 squared on both sides, so this guy passes away and this guy passes away. There's a g over here, there is a g over here. Okay, now we're gonna use an identity that says that the sine of 2 theta, where's my cursor? Here. Sine of 2 theta, that's equal to the sine of theta cosine of theta. Okay, and that thing is going to be very handy to us. 2 times this. Okay, so we now substitute. I'm going to continue over here. So from here, we know that 2 times sine of theta cosine of theta is going to be equal to the sine of theta squared over 2. Okay? So now we find that let me change colors. That with this square just can go with this guy over here, and our life can get a little bit easier. So we know that 2 cosine of theta is equal to the sine of theta, all of this over 2. Okay? From here, we just get rid of this 2 and set it to the other side. And this is 4 cosine of theta. It's equal to the sine of theta. Now we use another trigonometric property to know that 4 equals sine of theta over cosine of theta, and that is equal to the tangent of theta. And that's friendlier, okay? From there, we know that theta is equal to the arctangent of 4. And that is far much friendlier. And that is 134.78 degrees. Nope, that is, sorry for that, 75 degrees. 0.96 degrees. Okay? And that is the answer to this question. If you want to try this, in this formulas, where mouse, if you want to try this in this formula and in this formula, you're going to get exactly the same result, and that is 134.7, okay, for the range and for the maximum y.